right? So the bigger and angular fragments are called volcanic blocks, right? Volcanic blocks. You see here, so the igneous rocks are formed out of very hot lava or magma, right? So the extruded lava on solidification over the earth surface give rise to extrusive igneous rocks. So the magma on solidification below the earth surface, that is gives rise to intrusive igneous rocks, right? So this is below the earth surface and this is the above the earth surface, right? So the extrusive rocks occur as simple lava flow. So the intrusive lava rocks, on the other hand, that is assume different forms or different shapes, which in turn are influenced by geological structures. Those are occurring in country rocks and fluidity of magma, right? So some of the bigger and angular fragments, so those are called volcanic blocks or volcanic bombs. So if there are some what ruins, they are known as volcanic bombs, right? So smaller fragments, what are the smallest fragments? So those are called lapilli or cinders, right? Lapilli or cinders. So fragments are still smaller in size. So those are called volcanic sand, volcanic dust, and also volcanic ash, right? So a rock formed out of volcanic dust and volcanic ash. So that is called volcanic sand. So volcanic dust and volcanic ash. So a rock formed out of volcanic dust and ash, that is called tuff. Tuff, right? Tuff. Tuff. So the volcanic agglomerate or volcanic breccias, so that is the name given to the consolidation heterogeneous mass of pyroclastic minerals, right? Pyroclastic minerals. So you see, first of all, volcanic tuff. You see these pictures. These are the volcanic bombs. Right? Then next, this is the volcanic ash. You see these pictures. So this is the active volcanoes and you see the ash here. So these are the lapilli or cinders, right? So the lapilli means, so these small fragments between the size of a walnut and pea, right? So that is 2 inches to 64, 2 inches to 64 millimeters diameter. So which are ejected to a greater depth or greater distance than the larger agglomerate. So volcano tuffs also. So the finest of all, right? So fine grain. So the volcano dust, ash or sands, it may be deposited near the volcano or over the surrounding countries, right? Next, pyroclast. So what is the pyroclast? So the rock fragments throughout, you see here, rock fragments thrown at the time of volcano eruption, right? Volcano eruption. So these are called pyroclast, right? So these are described variously based on size and shape. So you see some of the pictures here. So volcanic ash and pumice stone. So basalt, gabbro, rhyolite, granite, porphyry, granite, right? The next one is intrusive igneous rocks. So we finished extrusive igneous rocks. The next, intrusive igneous rocks. So intrusive igneous rocks forms when magma is trapped deep inside the earth, right? So great groups of molten rock rise towards the surface. So some of the magma, it may be feed volcanoes on the earth surface, but most remains trapped below. So where it is cooled very slowly over many thousands of, many millions of years until it solidifies. And slow cooling, that means the individual mineral grains have a very long time to grow. So they grow to a relatively large size, right? So it means when magma is trapped, right? When magma is trapped or crystalline, so below the earth surface. So molten rocks rise towards the surface. So some of the magma, it may be feed volcanoes on the earth surface. So but most remains trapped below and it is very slowly cooling. And that means the individual mineral grains have a very long time to grow. So that occurs, there allows large crystals to form. So intrusive rocks have a coarse grain textures, right? So based on the relation of an igneous body, so with the attitude of associated country rock, so their forms are called concordant and discordant intrusions, right? So if an igneous body is parallel to or occur along bedding planes, you see here, these bedding planes of country rocks, so it forms is called concordant, right? Concordant. And also, other hand here, if it is cuts, you see here, cuts across the bedding planes of surrounding rocks. So that is called discordant intrusion rocks, right? So the injected strata remain more or less horizontal or parallel to the country rocks over wide area. So for examples, sills, laccoliths, and also lopolith, right? So discordant. So if it cuts, you see here, if it cuts across the bedding planes or bedding of the rocks in which they intrude here, right? So these are vertical to steepy incline and sheet-like bodies. And also it has thickness, so that is vary widely from an inch, right? Inch up to 100 feet, 100 of feet, right? So these are the injected through fractures and also joints and also weak planes, right? So this is the discordant and concordant intrusions, right? So some of the influencing factor. So in that, the magma, after it is formation under the influence of pressure exerted by a huge overburden, that is attempt to move upwards, right? Move upwards. So forcefully in its upward journey, when magma reaches sedimentary strata, their bedding planes offer convenient and suitable sites for magmatic intrusions and magmatic injections. So the bedding planes play an important role in the formation of igneous rocks, right? So, and the next influencing factor is the type of form of an intrusive igneous body. So that is the nature of fluidity of magma. So the fluidity or viscosity of magma that is dependent on its silica content, right? Silica, SiO, right? Silica content. So through magma, it has no fixed composition. So it is usually either silica rich or silica poor. So viscous magmas do not spread easily, but have a tendency to pile up at a place, right? So the basic magmas being less viscous, that is easily spread over large areas. So the three typical forms of igneous intrusions, that is silts, laccolith, and also bismuth. So those are can be explained by this property of the viscous nature of magma, right? Okay, first, the most common forms of intrusive igneous bodies. What are the? So, as observed here, so the dikes and also silts, laccolith and batholith. So, and also facholith, conolith, and also volcanic neck or plug and batholith, so etc. Right? So these are the lava flows and pyroclasts. So these are forms of extrusive igneous rocks, right? Extrusive igneous rock. So first of all, you see one by one dikes. Okay, dikes. You see the picture of dike here. So dikes and silts are the most common forms of igneous rocks, right? Dikes and silts are the most common forms of the igneous rocks. So the dikes are discordant type. Dikes are discordant type, and also this is sheet-like in vertical or steeply inclined, right? Steeply inclined and intrusive igneous bodies. So since they are sheet-like and they are narrow in width, right? And it have nearly uniform thickness. So that is with parallel sides. You see here these parallel sides. Right? So they occur cutting across these bedding planes of the country rocks in which they are found here, right? So this is like this, right? Cutting across these bedding planes of the country rock, right? So dikes and sills are the most common forms of igneous rocks, right? So during this forceful upward journey and magma that is intrudes through the discordant fractures, right? Discordant fractures here. And also cracks and crevices and also joints, shear zones or any other weak planes or zones. So subsequently, the solidification of this gives rise to dike. So some dikes may serve as feeding channels or passages for other igneous bodies such as laccolith, lopolith and also sills. So dikes may be horizontal, right? Horizontal or inclined or vertical. So steeply inclined or vertical dikes, those are extending to greater depth or common in the nature, right? So the dikes are important from some of the civil engineering point of view for the following some of the reasons. Why? Because they are undesirable at the sites of foundations of dams, right? Dams. Dams, because they introduce heterogeneity in the region and also their sides out to be weak plains, right? Weak plains. And also these dikes are like walls and also act as barriers for the flow of underground water also, right? Flow of underground water. So thus, this quartz vein, you see here, this is the quartz vein. So this quartz vein, they interrupt the groundwater movement, which in good or bad potential of groundwater in a region. So the dikes may give rise to new spring or seal old springs. So dikes may cause oil accumulation and thereby contribute to the occurrence of oil and gas deposits. So, as dikes are hard and durable, black and fine grain. So, they are used in making some of the statues, right? Statues and sculptures, etc. Right? These are the dikes. And next, volcanic necks. Volcanic necks. So these are the igneous bodies which seal the vents and conduits of ancient volcanoes, right? So these are somewhat cylindrical in shape, right? Cylindrical shape. You see here how to look like this image, cylindrical shape, right? So, and vary in, this is from diameter from a few hundred meters to a kilometer or more. So, the volcanic necks are circular or elliptical or irregular in plan. and it vary in diameter. So these are filled with crystalline, right? Crystalline. So these are filled with these crystalline rocks or fragmentary materials are both. So the volcanic necks are also volcanic plugs, right? So these are the igneous mosses which seal up the vents and ancient volcanoes, right? So this is the volcanic necks. Next, sills. So sills also this is similar to dikes in being sheet-like and intrusive bodies. But unlike dikes, so these are concordant. Sills are formed due to the penetration of magma into bedding plane or bedding planes of country rock. You see here the sills, right? So you see here, these are formed due to the penetration of magma into the bedding plates of country rock. You see here, this picture shows sills, right? So, and their spreading capacity. So that is depending on the viscosity of magma. So it is temperature and the weight of the overlying rocks. So basically, this magma being more fluid and more hard. So that is usually occur as sills, right? So during this sill formation, the ascending magma under great pressure pushes the overlying rocks upward and accommodates itself by intruding and spreading along weak bedding planes. You see here, right? Weak bedding planes. So sills being concordant, right? So on consolidation, look like beds themselves. So the sills which spread over larger areas. You see here larger areas. So these are generally thin and show uniform thickness. So the lava flows may resemble sill closely because both are relatively thin and horizontal, right? Thin and horizontal. You see this sheet-like igneous bodies that is spreading over larger areas, but they can be distinguished from one another easily, that as follows, right? So sills produce baking effects on rocks on both sides. So whereas in the case of lava flow, the baking effect is seen only on the lower side. You remember this, only on the lower side. So lava flows shown an irregular surface, whereas sills have more or less two flat and parallel sides. So this lava flow shows vesicular character on the upper surface, whereas sills have more or less two flat, right? Two flat and parallel sides. You see here like this. Okay. So the lava flows undergo kick cooling, producing very fine grained igneous rocks, whereas sills cool down rather slowly and therefore produce medium and coarse grain, right? Medium and coarse grain igneous rocks. So sills gives out minor intrusions, that is into the overlying rock mosses, whereas lava flow do not, right? So this is the sills. You see here, sills. Here also. Next, laccolith. Laccolith. So you remember same like laccolith, lopolith. Don't confuse that names, that words. Okay. So mind it, this laccolith. So laccolith like a sill, right? So laccolith is also a concordant igneous body. So it has a nearly flat bottom, nearly flat bottom. You see here, this one, laccolith. Okay. So, but it is convex shape, right? Upwards. So that is, it is domed shape, like you see here, this, like this, domed shape. Okay, domed shape. So when viscous magma is injected along these bedding planes, so as it cannot spread easily. You see here, right? So it pushes up the overlying rocks and piles up more at the place. You see here where it reaches the bedding plane and thins out away from it, right? So this gives the shape and inverted bowl to the igneous body, right? So the laccolith, it may also, you see here, this is locally, don't confuse here, laccolith, right? Dome shape, here, dome shape. So this laccolith may also be formed when the supply of magma from beneath, right? So it is more than that can be accommodated by lateral spreading. So this laccolith is relatively a small igneous body in the ground plane. It is either circular or elliptical. So this is depending upon whether the magma supply is from a cylindrical vent or an elongated fissure. So this laccolith causes the overlying rocks folded upward, the take a dome-like shape, right? Dome shape. So this is the laccolith structure. And then next, bismullith. Bismullith means when the magma happens to be highly viscous, right? Highly viscous. So the lateral spread along the bedding plane, it will be very less, and intruding magma acquires a somewhat cylindrical shaped body. So that is called bismullith body, right? So during the formation of this bismullith, since the overlying rocks are pushed up more or less vertically, they cannot bend unduly. So, but rupture along sides and number of actuate falls, you see these falls that is occur around bismullith. So the net result is that is igneous body appears as if it has punctured through the surrounding country rock. Such a form appears partly concordant and partly discordant. Right? This is the bismulic. The next, phacolic. Phacolic form. So when thick sedimentary are folded along the crest and troughs. So some empty spaces here, you see here, some empty spaces. Okay. So some empty spaces occurs here. So these spaces are readily occupied if magmatic intrusion get access to them, right? So on solidification, these appear as crescentic or lens-shaped across the axial plane. You see the shape crescent shape, right? Or lens shape. So these igneous bodies are called phacolics. So these are concordant igneous rocks, right? The next, lopolic. You see here. So the lopolic, this is a basin. Look like basin, right? So our saucer shape concordant intrusive body of enormous size. So its top is nearly flat, you see here. And the bottom is, how looks like, bottom is convex, that is downwards, right? So in the way, it is just the reverse of laccolithic shape, right? So laccolith is dome shape, center dome shape. So this is opposite shape, like this, right? So laccolith, very huge igneous body with a thickness approximately, that is 1 by 10 to 1 by 20 of the diameter, right? 1 by 20. So this is the lapolith and this is phacolic. So phacolic and lapolith are opposite shapes, right? So the next one is batholiths. Batholiths, these are the, you see here, this is the batholith. So these are largest known intrusive igneous bodies. That is characteristically, those are occurring in mountain regions. So these batholith sides sloping away from each other, which makes them larger and larger downwards, and then extended to, it is very greater depth, right? So they occur as core bodies of folded mountains, and it is appear elongated and along mountain ranges. So by, that is which of their position, they appear as mountain roots, right? Mountain roots. So since they are deep seated, that is only very prolonged erosion exposes them on the surface, right? You see here, this is the Batholith, right? So dikes and also silts and volcanic necks and laccolith, lopolith and bismuth, batholith, right? So these are the intrusive igneous rocks. You see some of the pictures here. This is the real picture of the dike, right? Real picture of the dike. You see these bedding planes here. So bedding country rock. So this is cutting with dike, that is shape. Okay. So some of the extrusive igneous rocks images you see here, how forms extrusive igneous rocks here, and also you see here extrusive igneous rocks, and you see here. So this is cooling of lava, right? This is coming from the volcanoes, that is heating lava. This is cooling lava. This is also cooling of lava. You see here difference between intrusive means this is, you see here also same. These are the extrusive like this. This magma coming out from the volcanoes. This is called lava, and also these are called extrusive igneous rocks. So these are the intrusive igneous rocks. So you see some pictures of volcanoes, right? Okay. Today topic is over. So what is that today topic? Forms of igneous rocks, right? Forms of igneous rocks. In that we have two types, that is extrusive and intrusive igneous rocks, right? Okay, today class is over. I will take tomorrow.